Hi guys, today I'm gonna explain about the strong inversion and the threshold voltage and capacitance and between capacitance and voltage characteristics and the IV curve of MOSFET. Okay, let's start. First, we I will draw the Venn diagram about the NMOS and PMOS. First, I will draw the NMOS. First, I will draw the N plus polysilicon and dioxide like this. And the important thing is we have to maintain this offset, this this offset. We have to think about this offset. So we can draw the diagram like this. And maybe we use the pit stop, so the Fermi level in here and the intrinsic Fermi level will be here. So the condition about the strong inversion is phi b, the phi s to phi b. At that time, we can say the strong inversion. The the b- the difference between here and here is phi s, and between the intrinsic Fermi level and the Fermi level is phi b. So here between this is phi b and this is the phi v. So if if the phi s is the 2 phi b, we can call this situation is this phenomenon is the strong inversion, and the strong the voltage to make the strong inversion. And at that time, the voltage, we call that the voltage is threshold voltage. The we can calculate threshold voltage is waiting is fully flat band voltage plus 2 phi b and plus root 4 the silicon epsilon and q and the doping concentration and 5b over c ox. This is the theorem about the VT. And if we withdraw the PMOS, we can draw same. Mm, okay, if we put the gate bias, the resistance about the dioxide is high, so the slope between this point and this point will be very highly. So you have to know about this fact, and we can draw the and in PMOS we have to maintain this offset and here, so we can draw like this. And the same principle between the gap up here is phi s. And between the Fermi level and intrinsic Fermi level is phi b, and here is also phi b. So in PMOS is the same. If the phi s is to phi b, we can call this phenomenon is strong inversion situation, and the voltage make the strong inversion is threshold voltage. And in PMOS, the VT, the threshold voltage calculation is the flat band voltage minus phi b and minus this. This is the threshold voltage in PMOS. And next is the CV characteristics. We can explain this is use the diagram. So I can draw the CV curve, CV, like this. And we can divide this like this. And this point is strong inversion. And here is defletion. And here is weak inversion. First, we have to know about the capacitance. Capacitance means how many charge the how many charge can storage in the capacitance. So in this region, the capacitance is so constantly, but if we get the bias on the gate, you know the if we put the bias on the gate, the graph like this, and this in surface there will be the depleted. So the there is no charge, so the capacitance will be lower, and if we the, put the bias on the gate too many, there will be the weak inversion situation, and the capacitance will be come back to the like this. And if we put the gate bias very highly in the at the time in the surface, there will be some inversion channel, so the current can flow very well. So the capacitance will be drawn like this. This is the explain about the CV curve. And next is the IV curve about MOSFET. And I'm gonna tell you about the saturation and the pinch off. First, if we the diagram about the MOSFET, we can draw the source channel drain diagram like this. Source channel drain, and with we get the bias on drain to plus, the graph the graph will be drawn like this. So the current can flow into the source to drain. So the IV curve will be drawn. So like this. This moment means drawn like this. And but if we get the bias to drain to plus, the current will be flow like this. But at the time, at some moments, there is the pinch of edge of a saturation because the current can flow to infinity. So the graph will be drawn like this, and we can call this point is the pinch of point, and this situation is saturation. And with if we the VGS highly, the graph will be drawn like this, like like this. So we can check the pinch of point can move to right from the zero volt, and we can draw the pinch of point graph like this. And we can also notice the one thing is in the saturation region, the MOSFET can be used like the current source. And this region is linear region. And here is saturation region. And we can calculate the ID current in drain is there are two type is in linear condition is length width over length and mu Cox, and we VGS minus VT to H and VD and VD square over 2, and but this this is very small, so we can approximate, and so we can ignore this, and we can call this voltage VGS minus threshold voltage. We can call this is the VOV. It means it's overdrive voltage. And in saturation condition, we can calculate the ID is 1 over 2 and width over length and mu Cox and VGS minus V threshold voltage square. And in here, also we can say this VGS minus VTH is VOV, and it means it's overdrive voltage. Okay, today I'm gonna finish the explain and thank you for watching this video.